32% of these track-caused accidents are caused by broken rails or joints on mainline tracks in the USA. There's this particular kind of crack that causes those accidents, and we call this defect a detail fracture, and it's internal, so the only way you can really find it is through specialized technology. I want you to keep in mind something that everyone's done. You take a paper clip or a coat hanger and you bend it. So as trains are going over the rail, each wheel is bending the paper clip or the rail, if you will. So the rail's accumulating damage, if you will, and eventually there may be a crack that forms. And eventually that crack will start to grow. And because it gets bigger, now you have maybe a better chance of finding it because of the detection capability of the technology kicks in. So here the detector car goes over it. And so there are two things that could possibly happen. One, you actually find the defect because it's bigger than it was before. But the other case is more severe, where you actually missed it. And in this case, the crack may actually grow until the rail fails. But because of this horizontal defect, when the ultrasonic signal comes in, sometimes it might bounce off of that and you miss it. And it isn't until it actually gets a little bit bigger where the ultrasound actually can see it. And the other thing that may happen is, as you're competing with how much fatigue is going on, the rail is actually losing material. In this case, there's some kind of head wear. We know what the size of that defect was at the time of the accident, and we back calculated what the size of that defect would be at the time of the last inspection. We assisted the NTSB in back calculating what the size of that defect was at the time of the last inspection. And in this particular case, because of how much wear there was, this is a fairly small defect. So it's possible that it was missed because it was so small. But the growth rate was very rapid because of the amount of wear. That's something that we need to look at, is this combination of wear and the fatigue. We've tried to develop this method to determine how frequently to do these kinds of inspections. You're actually asking the railroad to count how many broken rails they have, and then they count how many defects they find from these detector cards. And here is this, what we call a performance target, which is how many broken rails can you actually tolerate. So the national average is basically 1 broken rail per 100 miles. So you input this into the algorithm, and based on some of the assumptions that we've embedded into the algorithm, it will tell you how many rail tests to perform in the next year. And here at the Volpe Center, we've been involved with looking at how fast these cracks grow, and we've correlated those with experiments that were done at the Transportation Technology Center. The last thought I want to give is another type of defect, and this is caused from corrosion. So you can see the rust that can occur in a rail. And in this case, there's actually a kind of defect that forms in the base. More than a year ago, there was this type of accident that occurred in the tunnels, one of the tunnels under New York City. And this came to our attention because there is a lot of water underneath the tunnels. But now, as forewarning, because of what happened in Hurricane Sandy recently, now with salt water being penetrated into the tunnels, I think this is something that railroads will probably have to look a little bit more to think about in the future. Because of the salt water, maybe this kind of corrosion defect may occur more frequently.